Hi everyone, and welcome to this video on fractional indices. Now, in the previous videos we were looking at negative indices, and that came about through our curiosity of looking at the pattern of numbers, so like 10 cubed, 10 squared, 10 to the power 1, 10 to the power 0, and it naturally took us onto a negative journey. But the same thing happened with fractions. We're like, well, what happens if we have fractions? Now, if we use our knowledge, so for example from a previous video, we know that 3 squared times 3 cubed is 3 to the power 5. We know that, that's a fact. So when we keep the base values the same, we can add the powers. So what we started to do with fractions is we looked at things that made a whole number. So we know that that is going to equal 9 to the power of 1, or just 9, if we want to be better. So what this means is when we have power over halves, it must mean one thing times exactly the same thing must equal 9. Well, if that's the case, these both must be 3. So 3 times 3 is 9, so that means 9 to the power half is 3. Now you'll notice I chose a number that was easy to square root, because, well, we probably wouldn't have started with that, maybe we did, but if we put a number like 8 here, for example, I wouldn't actually be able to do anything with this. I wouldn't be able to answer that question I just said, like what two numbers times together to make 9. If that was an 8, I'd just be using root 8, or I'd be using surds, and I would overcomplicate it when we're trying to find patterns in things. So using our knowledge of multiplying indices with the same base value for the same reason, this is 16 to the power of 1 because half add a half is 1, or 16. So this time we're asking the question, what two things multiply together to make 16? Well, that must be 4 times 4. So 16 to the half must be 4. Well, hopefully you've spotted something now. So anything to the power of a half means what we do is square root. Okay, well that's to the power of a half. Well, what do we think the power of a third would do? Okay, so if the power of a half is square root, have a little think now and then press play when you're ready. Okay, so let's explore. Same thought process, okay? So if I have a third, well, I'd need 3 of these added together to make a whole one. So that's why I have 3 of them. So that would be 8 to the power of 1, or even better, just 8. Now these 3 numbers can't change because is 8 to the third every time. They're exactly the same. 2 can't suddenly be a 6 because it feels like it. So this means what number times by itself 3 times is 8? Well, that must be 2. So 2 times 2 times 2 is 8, so 8 to the third must be 2. Now, if I've taken a number 27, you'll see why in a minute. Same process, that is 27 to the 1, or even better, just 27. So what number times by itself 3 times gives me 27? 3. 3 times 3 times 3. So we know 8 to the third must be 2. We know 27 to the third must be 3. What is the pattern? Is that what you predicted? Maybe, I hope so. So to power of a third means we cube root it. So let me just write the other one. So power of a half means we are square rooting. And you can put a little 2 there if you want to, but we don't often. So cube root. So what about this one? What do you think that will do? That's right, hopefully you said the 4th root. Okay, so that denominator value is our root value. So then hopefully you must be thinking, well, okay, what happens if we go away from the unitary fractions? What about 2/3, for example? So let's take this one. We know the cubed is the root value. So what does that 2 do? Well, we know this is true, right? So 27 is equal to 27 to the third times 27 to the third times 27 to the third. We know that is true. Well, what is 27 to the 2/3? Using the same logic, so what powers can I use to rewrite it like this? So we've got 27 to the third times 27 to the third. 1/3 plus 1/3 is 2/3. That is true. That's just using maths that we already know if you're watching this video. Well, we also know 27 to the third, that means cube root. Well, that's 3. So that's 3 times 3. So we know this must be 9. Well, also, we can see that it's the same thing times by itself. So we've also got here 27 to the 2/3 is 27 to the 1/3 squared, or the cube root of 27, which is the same thing, 1/3 cube root squared. So what is that 2 doing? Well, it's our power value. Okay, that's what's happening at the end. So the denominator, you can see, is our root value, and the numerator is our power value. So if we want to write it in general terms, the b is our root, the a is our power. And I will say that it's important to realize that this is the same thing. And I'll show you this in a minute. So the power value, because of BIDMAS, or if you're watching in America, you call this PEMDAS. I just write both of them. I often teach my students both because this is a really nice discussion point. Now, indices or exponentials, it doesn't matter what order you do those. So you can do, these are both indices. Okay, this is one indice, or you could look at it as two separate ones being multiplied together. So it doesn't matter if you do the root value and then the squared, or the power value, or the power value and then the root value, because of BIDMAS or PEMDAS. Alright, so let's have a look at some. So it's easy to remember to power of a half means square root, so that is square root of 25, which is 5. Now you could be writing plus or minus 5, but with indices we're only really interested in the positive value. So to the power of third, that means cube root. Now be very careful you don't write this. That is 3 times root 64. That is wrong. The 3 must be smaller than your letters. So that's 4 times 4 times 4. And don't worry if you're cube rooting, it's not that fast. You'll soon get used to it. But just think of small numbers. Okay, they're never going to be big numbers. Right, okay, a little bit harder now. So we've got the root value is cubed of 8, and I'm going to square that. And just remember, I could have done it like this. Oh, not like that. Like this. So the cube root of 8 is 2. 2 squared is 4. So, or I could have done the cube root of 64, which is also 4. This up there. Okay, so same one, same fractional power rather. So the cube root of 125 squared. I definitely don't want to square 125. So this method here would be the worst choice. So the cube root of 125 is 5. 5 squared, 25. So got a few more. So we've got the fourth root. So the fourth root of 16, and we're going to cube that. Now the fourth root is really easy. You just square root and square root again. So square root of 16 is 4. Square root again is 2. So we've got 2 cubed, which is 8. And this one, there's just a unitary fraction, so we don't have to worry about the power value. I could put it there if you want me to. It's good practice. So square root is 9. Square root again is 3. Well, what we can do is we can mix this with our negative knowledge. So when we see a negative, I always think it's easier to write it as a fraction. So we see a negative, we reciprocate, and the power is now positive. And we explained why that happens. It's not some magic. It's a pattern that exists, and that's how we do it, just to get there quickly. Now, anything with a base value of 1 is just going to stay the same. Okay, but technically 1 is being raised to this, but 1 raised to anything is still 1. So 32, we've got the fifth root of 32. So I'm going to write this in here. Fifth root of 32 squared. Now the fifth root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 32. If you're rubbish at base or powers of 2, 2048 is a really good game you can download and play. It's a bit addictive, but it's a really fun game. I teach you all about powers of 2. So it's 2 squared, which is 4, so it's 1 over 4. Again, we've got a negative, and in this instance, I think it's easier because you don't forget to reciprocate it, because it's a fraction. It's definitely easier to reciprocate this one than is this one. So we've reciprocated, the power is now positive, and it's a half, so it's square root. So square root of 81 is 9, square root of 16 is 4. Now, the next stage is to solve with indices. Now, super easy, let's call this one stage 1 with examples like this. So what is x? Solve for x. 5 raised to something is 25. Well, that must be 2. That's easy. So some of them, stage 1, you can do just by looking. 3 raised to something is 27. Okay. 3 to the power of 3 is 27. Nice and easy. Let's go to stage 2. Now, some of you may have memorized these and looked at them for long enough that you can just see it, but you'll notice that 9 can't be raised to any integer value to get to 27. So in this instance, whenever I see indices, I always think base values, and your base values must always be the same for you to apply any of your laws or for you to see patterns. So you've just got to find a base value that would suit both of these. So 9 can be written as 3 squared. So instead of writing 9, I can write 3 squared, and 27 can be written as 3 cubed. Now I have the same base value on each side. But on the left hand side, we've got this power to power. So that's the power to power rule, which you can multiply the powers, again, much earlier in your indices journey. And we have 3 cubed on the right. So that means 3 raised to something, 2x, is equal to 3 raised to 3. Well, that means 2x must equal 3 because we're raising it to the same, the base is the same. So whatever we raise it to, if they're going to be equal, the powers need to be equal. So for example, you can't, this is rubbish, yeah? That can't happen. But you could say this is true. Yeah, so if the base is the same, the powers have to be the same if it's equal. You know, if it's not equal, then that's a different story. So x must be 3 over 2. So if we square root it and then raise it to the power of 3, we'll get 27. So again, these values are not the same. So I could have written this question slightly different. So I could have written it as that, for example, which is the same thing. I don't think that's a good step at this stage. But what I will do is write that. Now, whenever you see this 1 over and you have this power that's positive on the bottom, you should be thinking negative powers. Now we can see here, x is equal to minus 2. As soon as you make the base values the same, you just compare the tops. Sometimes you may have a bit of a funky equation to solve. I'll talk about funky. Let's go to stage 3. Wow, look at that. Now you may be wondering, well, what if you can't make the base value the same? Well, don't worry, we're just not going to ask you that at GCSE. That's an A-level topic using logarithms. One to look forward to. So 81, 27, they're not the same number, but can I write them as the same base? And always think small. So normally you can do this with either a 2, a 3. You wouldn't look for 4 because 4 is 2 squared. So you're looking for 2s, 3s and 5s, and if it's not in them, you've probably made a mistake because it normally is. So 81, that is 3 to the power of 4. 2x plus 1. And 27 is 3 cubed, x minus 2. So now I've got the same base on left and right. We've got the power to power, so let's just multiply those. We've got 8x plus 4. Don't forget to multiply both the terms by the 4. And we've got 3x minus 6. So the powers must be equal because the bases are the same. So we have a year 1 two-step equation. So x is on one side, numbers on the other, so x must be minus 2. Now the wonderful thing about equations is you can always pop your answer back in and the left hand side should equal the right hand side. So for example here, if you did 81 to the power of, what's that, minus 3, work it out, and then do the same with this one, if it's the same, you know you've got the answer right. One more for us to look at. So 8 and 16, they're not the same. So let's think 2's. Can I make 8 a base of 2? Yes I can, 2 cubed. So it's 2 cubed to the power of 2x, and 16 is 2 to the power of 4 raised to x minus 3. Power to power, so let's multiply the powers. 4x minus 12, set them equal to each other. X is on one side, numbers on the other, So in this instance, x was minus 6. Okay, that's it. So just time for you to practice all of these new rules. Best of luck.